Hi everyone, I'm Doug from DigiPen in Redmond. In this video, we'll learn a new way to move sprites around. Imagine riding your bicycle at a speed of about 5 meters per second in a straight line. After 10 seconds, you'll have gone about 50 meters. Let's visualize this. This dot represents the start of your ride, and this dot represents the end of it, 50 meters away. You got this far because your speed is 5 meters per second, and 5 meters per second times 10 seconds equals 50 meters. Your speed tells you how far you will go in those 10 seconds. Now let's chart this bike ride on a Cartesian coordinate grid. We'll choose the origin of the system to be here, representing the start of your trip. And after traveling at 5 meters per second for 10 seconds, the end of your trip is right... well, where is it? We don't know. We don't have enough information. Speed tells you your distance traveled after those 10 seconds, but it doesn't tell you your new position. To know the new position, we need to know both your speed and the direction you were moving in. Combining an object's speed and its direction gives us what we call its velocity. An object's velocity is the rate of change of its position. If your direction is due east and your speed is 5 meters per second, then you'll be here after 10 seconds. If your direction is the same, but your speed is only 2 meters per second, then you'll end up about here. If your speed is the same, but your direction is south, then your trip will end down here. If you're traveling this way, a little bit west of northwest, then 10 seconds later, your position will be here. Velocity is an important concept in video games, where we often move things around. And how can you move something if you don't know where you're going to put it? In Scratch, we've actually already been using velocity all along, whenever we use the move block. The move block has a value field that determines how far a sprite will go each time the block is run, representing the sprite's speed. We can control the direction it will move in with its direction variable. Changing either one changes the sprite's velocity. Note that a sprite's velocity is composed of two numbers, speed and direction. This is a common way to represent velocity, but it's not the only way. We can also break an object's velocity into two parts, its horizontal and vertical components. Let's go back to the coordinate grid and look again at those bike trips you took. Here, the x-axis represents movement to the east or west, and the y-axis represents north and south movement. When you pointed your bike straight east with a speed of 5 meters per second, you got right here after 10 seconds. Along the x-axis in the positive direction, you're 50 meters away from where you started. Along the y-axis, you haven't moved at all. We can say that your velocity was positive 5 meters per second in the x direction and 0 meters per second in the y direction. When you were heading south instead, you ended up here. Along the x-axis, you didn't move, but along the y-axis in the negative direction, you're 50 meters away from the origin. Your velocity was 0 meters per second in the x direction and negative 5 meters per second in the y direction. And when you were going this way, about 53 degrees west of north, your 10-second bike ride got you here, 40 meters to the left of the origin and 30 above it. Your velocity was negative 4 meters per second in the x direction and 3 meters per second in the y direction. What if you didn't move at all? If you just stay in one spot, then your position after 10 seconds is the same as it was before. In this case, your velocity is 0 in both the x direction and the y direction. Breaking up an object's velocity this way has some advantages in game programming. For example, it makes it easy to simulate a ball flying through the air. If someone throws a ball up and to the right, then we can say they gave it a positive x velocity and a positive y velocity. As the ball flies, its x velocity will not change, but its y velocity will be affected by gravity. While the game is running, we can nudge the ball along according to its velocity. Over time, these nudges cause the ball to follow a realistic arcing path. In some games, the hero can move in any direction and they don't have to face the direction they're going in. In Scratch, a sprite's direction variable controls both its rotation and which way it goes with the move block. If we could only use the move block to move, then it would be a bit of a pain to allow the hero to rotate freely like this. But if we give the hero separate x and y velocity variables, and then move them with the change x and change y blocks, the hero can turn however they like while they move in any direction. Let's improve Scratch invaders by giving the hero a velocity and using that to move them around. Load what you've already done in that project, or visit the link in the description below and then click the See Inside button. Let's take a look at the hero sprite's code area. When the green flag is clicked, the initialize function is called, where the hero speed variable is initialized. Then, a little bit later in the hero's main forever loop, the handle movement function is called. Here, we use a group of if-then blocks to check the movement keys. If the appropriate key is held, then we change the hero's direction variable and use the move block to move the hero an amount equal to their speed. This happens again and again as long as the game is running. Our new movement system will remove the move blocks. In their place, we'll set the hero's x and y velocity. Then, at the end of the function, we'll apply the velocity to the hero's position, thereby moving them. Let's get started. First, we need to make two variables, one for the hero's x velocity and another for their y velocity. But this time, we're going to make them a little bit differently, so listen closely. Click the orange Variables category on the left, and then click the Make a Variable button. The Make a Variable dialog will appear. Type the name x velocity in the name field, and then click the For This Sprite Only option, and click OK. The For This Sprite Only option means that this new variable only shows up in the block palette for the current sprite. This allows us to make velocity variables just for the hero, and then later we can make velocity variables for the bullet and for the enemy and anything else we end up making. These variables are all kept separate from one another, so everything remains tidy and organized. Click the Make a Variable button again and make another variable called y velocity. Don't forget to click the For This Sprite Only option. Now we should initialize our new variables. Find the Set block in the block palette. Drag 2 copies of it into the code area and add them to the body of the initialize function. Set the first one to x velocity and set the second one to y velocity. Leave their value fields set to 0. The hero is expected to change its velocity throughout the game, but it should begin motionless. Now we turn our attention to the handle movement function. The first thing we should do is remove the code from it that we won't be using anymore. Drag each of the point in direction blocks in the body of the handle movement function and drop them in the block palette to delete them. This will also take the move blocks out. Now we need to set the velocity variables inside the if-then blocks according to which keys the player is holding. Find the Set block in the block palette, drag 4 copies of it into the code area, and attach one inside the mouth of each of the if-then blocks in the body of the handle movement function. In the if-then block, with the key pressed block checking the up arrow, select y velocity from the set block's variable list. In the block checking the down arrow, again select y velocity from the list. In the block checking the right arrow, select x velocity, and in the block checking the left arrow, again select x velocity. When the player holds the up arrow, we want to set the hero's y velocity to the value of the hero speed variable. Find the hero speed reporter block in the block palette and drag and drop it into the value field of the set block in the up arrow's if-then block. When the player holds the down arrow, we want the hero to move vertically with the same speed as when they move upward, but we want them to move downward instead. This means we need the negative of the hero speed variable. Recall how this is done. We just subtract the variable from 0. Click the green operators category and find the minus block. Drag and drop it into the value field of the set block in the down arrow's if-then block. In the left value field of the minus block, type the number 0. Then, right-click the hero speed reporter block we just put in the previous set block and choose to duplicate it. Put the new copy in the right value field of the minus block. When the player holds the right arrow, we want to set the hero's x velocity to the hero speed value. Right-click either of the hero speed reporter blocks from before and choose to duplicate it. Put the new copy in the value field of the set block in the right arrow's if-then block. Finally, when the player holds the left arrow, the hero's x velocity should be set to negative hero speed. Right-click the minus block from before and choose to duplicate it. Put the new copy in the value field in the remaining set block. Now it's time to apply the hero's velocity to their position. Click the medium blue motion category and find the change x and change y blocks. Add one of each to the end of the handle movement function. Click the orange variables category and find the x velocity and y velocity reporter blocks. Drag and drop the x reporter block into the value field of the change x block, and drag and drop the y reporter block into the value field of the change y block. Click the green flag and try moving around. Uh-oh, the hero keeps moving after you let go of the movement keys. This isn't what we want. The reason this is happening is that the hero's velocity variables are never being reset to 0. The only time they're being changed during the game is inside these if-then blocks, which means nothing is happening to them unless the player presses a movement key. To fix this, we just need to set the velocity variables back to 0 before we check for player input. Find the set block in the block palette. Attach 2 of them inside the body of the handle movement function, up here, between the define block and the top if-then block. Select x velocity for one of them and y velocity for the other. Now the velocity is being reset properly. Click the green flag to try it out. Let's recap what we've learned in this video. First, we considered the relationship between speed and distance. If an object travels for 10 seconds, its speed tells us how far it will go in those 10 seconds. Then, we learned that if we combine an object's speed with its direction of movement, we get its velocity. Next, we learned that an object's velocity can be broken into 2 parts: its velocity along the x-axis and its velocity along the y-axis. We saw that breaking up velocity in this way makes some things easier in game development, such as the path of a ball moving through the air. Finally, we improved the hero's movement code in Scratch Invaders by using variables to store their x and y velocity and then applying those values to make them move. In the next video, we'll apply the technique of cloning sprites to the enemies in Scratch Invaders.